Hello guys, you are welcome to my channel. It's been a while here we have dropped video on my YouTube channel. I'm busy with some research in chemistry. So this afternoon I'll be talking about endothermic and exothermic reaction. So class, what is exothermic reaction and endothermic reaction? I want you guys to pay max attention to the class because for jam students, YF students and NECO students, you will come across questions on this each of reaction. And to the jam students, I will need you to pay more attention to the class now. So as you do, let's start. What is exothermic reaction? So we can say exothermic reaction can be defined as a reaction in which its energy is given out to the surrounding from a reacting system. So now, how do we prove that its energy is given out to the surrounding? I'll be using two illustrations to explain that. That's of the graphical method and the one in which you can go to the lab to what? To experiment on. So class, if I should say that it is given out, how does it give out when we have a reacting what? System now. So for example, if I should have a beaker like this, are you with me now? So the beaker contains the reacting system, and we have all this surrounding the what? The beaker. And what are the things that surround the beaker? They are the its energy. So I have it here. I have it here. I also have what? The it energy here now. So how does it is given out, or how does this particular energy produce it within the what? The surrounding now. If you should have a reacting system being heated with it, it's going to produce an energy called that the energy of the reacting system decreases. So we said energy of the reacting system decreases. So, and if the energy of the reacting system should decrease, then the energy surrounding the system will increase. So we said surrounding energy increase. And one thing you should know that for this reaction system to produce decrease in energy, then this surrounding you are seeing here now will give rise to what? Increase of energy that surround that particular system. And with that, this one will become hotter to produce more heat. Again, if the reacting system should collide with it, we are going to have that the energy of the reacting system decreases, while the energy that surrounds that particular reacting system increases. With that, we are going to have a hot object. So now, with that particular illustration, I can also say that when substance A reacts with substance B, the loss of its surrounding will produce substance C. That's another way. of explaining it now. When substance A reacts with substance B, there will be loss of energy or loss of heat, which will produce what we call substance C. And with that, we can have A plus B, but this is we have C. So the heat energy produced will be negative. So to the Jambite and the white student, in as much as you come across a question like this, or any equation given, can be it in equilibrium or under the heat of reaction, because equilibrium and endothermic and exothermic reaction, they work hand in hand together. So now, if you have any particular equation given that it is a negative sign, it means that such equation is an exothermic reaction. That is, the energy of the surrounding or the energy of the reacting system decreases while the energy surrounding the system increases. That is the meaning now. So let's show the graphical illustration of this exothermic reaction. So we have the illustration to be like this. So we call it reacting peaks of exothermic reaction. So now I'm going to use this here to explain it. Here is the reactant side, while this place we have it to be the product side. Mind you, this change in heat is called the it's called the heat energy change, or change in heat energy. So it's that now. Here is called the potential energy. So now let's show how it goes. We have 1 here, we have 2, I have 3, I have 4, 5. So now looking at what you have on the board about exothermic reaction, the energy of the reactant, which is A plus B, is greater than the energy of the product, which is C. So it's that I can say I have this, I also have this. So here we have the change in it to be negative. So while this place we have this arrow, this is called activation energy. Why this particular place is called activated complex or transition states. So now, when a substance A reacts with substance B, the heat energy loss within the surrounding will produce a reacting substance, which is what? C. So to the Jambites, if you have a question like this in your jam and you are being asked to what? Check which part is activation energy. In jam, they can decide to label this particular place X, this place to be Y, and here to be Z. With your knowledge, we know that our Z is change in heat energy, and here we know it is called activated complex or transition state, while our X is known to be activation energy. So now let's take the last one, which is an endothermic reaction. So for endothermic reaction, if exothermic gives us heat, we should all know that endo we absorb heat. So with that, we can say endothermic reaction can be defined as a reaction in which heat energy is absorbed within surrounding to form a reacting system. So now, under the exo we said the heat energy of the reacting system decreases while the energy of the surrounding increases. Here under the endo, the energy of the reacting system increase while the energy of the surrounding decreases, making the reacting system that surround it to become cooler. Are you getting it now? So now, how do we explain this? That the energy of the reacting system increases while the energy of the surrounding decreases, making the reacting system that surround it to become cooler or colder. So now, let's show we have beaker here. So we know that here will be the reacting system. So we can say here produce energy of the reacting system increases. So the surrounding here decreases to make this particular thing to become cooler. So now don't forget that here we have our heat, here we have our heat, here we also have our heat. So now the only difference between this exo and endo is that for every exotemic reaction the energy of the system decreases while the energy of the surrounding increases, while for every endo the energy of the reacting system increases while the energy of the surrounding decreases, and to make that particular surrounding to become what? Cooler. You can try this in the lab to confirm it. So now let's show the graphical explanation of endothermic reaction. And before we do that, if substance X reacts with substance Y to absorb the particular heat, so you can say plus heat to produce Z, so we say X plus Y will give us what? Z. So the change in heat energy will be positive. And if change in heat energy is positive, it means that for every equation given in your JAM or WAEC, if you have any chemical equation given that have a positive sign, you should know that is what? Is an endothermic reaction. So now class, let's check the graphical illustration of endothermic reaction. We have this. Mind you, the energy of the polar side, here we have Z, we have X plus Y. So with what you have here, we can say we have this now. Mind you, don't forget that when talking about these heats of energy of reaction now, we already have our activation energy to be in this particular place. So it's that this arrow will be here, then our heat energy change will be in this place. So we have it to be what? Here. Or we can decide to make it like this. Heat change is equal to positive. So here is the transition state, which is known as the activated complex, while here is the activation energy. So now we can decide to label this place 1, 2. Here we have it to be 3. We can play this with 4, and our transition to be what? 5. So in your jam, you can be asked that where is your activation energy what located? The value here is what? 4, and the unit for that is kilojoule per mole. So guys, I think I've exposed you guys to what we mean by an exothermic and endothermic reaction. Don't forget to subscribe, like, share within your colleague, and don't forget to watch to the end.